Bismillahirrahmanirrahim. Okay. Okay. Now let's go. Okay. Now our journey begins. Happy everybody?
Yes.
Okay.
It's 4
Write
o'clock.
an algorithm to enter your first and last names and display your full name. This is a problem, right?
An algorithm to enter your first and last names and display your full name.
Okay. So this is a problem. So if you are asked to write an algorithm where you will enter your first name and last name separately. Okay. For instance, if you will tell me, if I tell my first name and then my last name and then you will tell my full name. How do we do that? Think about, but in daily life we know how to do it, but we have to think computationally. How computer do that? How computers do that, right? And how can we write later? When we write, we will first write an algorithm, then we will write a pseudocode, then later we will write a program code from here. Okay, so in general, how do we do it? For instance, this is a flowchart. Okay, so algorithm can be depicted several ways. I told you by writing a flowchart, right? So look at flowchart or a picture. So this flowchart says, what does this say? A flowchart has some specific symbols. For instance, all begin and end has oval shape. Okay. By looking in an oval shape, you will see either it is a start or it is a end. So good. Now there are some arrows. You see arrow, up arrow or down arrow or left and right arrow. These are showing directions. So then after beginning, you have to start from top. That was the start, and then you need to do the next step. So what is the next step? Enter your first name and last name, right? So when you for input and output, this is a flowchart. Flowchart has some specific symbols. Okay, so for input and output we use parallelogram type symbol. Okay, and for where do we use operation, make any operation, then we use this rectangular symbol. This one, middle one is rectangular.
Slow down. So begin and end, you said oval shape.
Yes.
What does it mean?
Either start or end.
Input and output.
No, the begin is start. That's the start symbol.
And last is
End.
Said a parallelogram sign.
Okay, parallelogram is for either input or output. Parallelogram, the second one here is enter your first name and last name. It is input or output. Wherever you see the parallelogram sign, you will understand whether it is an input or output. So all input or output steps are written with a parallelogram block. Okay, and arrow are used for showing direction.
Okay.
From begin, that after begin you need to come this direction. You have to after begin, then you have to start. You have to enter your first name and last name. Then you see rectangle, right? Rectangle is the middle one is rectangle. Rectangle is used to do some operation. What is the operation over here? It says concatenate. It has some verb. Concatenate means combine. Concatenate first name and last name to form your full name. Okay.
So this is.
So we need to write some codes over here, some steps over here, right?
Okay.
One or more some steps over here in order to combine first name and last name.
Okay. This is rectangular.
Yes, rectangular. Wherever we need to do some operations, any kind of operation, then we will put that operation within rectangle.
Then what operations do we have to do inside a parallelogram?
No, in parallelogram we will put either input or output.
Look at the picture.
Look at the picture.
Look at the picture. Input and output is
Parallelogram.
operations are rectangular.
Okay, and begin and ends are oval shape. Okay, very pretty simple, right? Okay, and why do we use arrow?
To show
For the direction. That means without begin in our first step, right? Then the second one will be enter first name and last name, right? So that means, and then after that we have concatenate first name and last name.
Concatenate.
Nate. And comments combine.
New word.
Okay.
Concatenate.
Yes. Combine. Okay. Okay, so this is a flowchart algorithm.
the whole thing.
Okay, now we can write, this is an algorithm. Okay, this is a solution. If I ask someone else, show me, depict me how to enter first name and last name and display full name, if someone gives me this process, this is correct, one way to solve my problem, right? So what is my problem over here? What is my problem?
Problem is show display your full name
From your first
using
name, yeah, by using first name and last name. Okay, that was my top one, is my problem, and this is this picture or flowchart shows a way to solve this problem, right?
Yeah.
Okay, so now if we implement this flowchart, we can, this is an algorithm. Okay, as we know that we can write algorithm by flowchart or by writing pseudocode. All pseudocode start with begin and ends with end. So you see at the top begin and at the end, right? All pseudocode starts with a begin and ends with an end. So all flowcharts start with a begin symbol and ends with an end symbol. Similarly, all pseudocode begins with a begin and ends with an end. Some people say start, end, start, finish. That's okay. Okay. Some people say instead of begin, some people say start.
Okay.
That should be good. Okay. So by looking start or begin, we know that this is the starting point and this is the ending point. Okay. So then this is the first step. Okay. It says enter your first name and last name. Okay. The first step, right?
Yes.
The second step is concatenate first name and last name to form your full name. And the third one is display your full name, right? This is kind of solution, right? Our problem was how to display my full name by getting my first name and last name, right?
Yes.
I got my first name and last name. I was given my first name and last name, and I have to display my full name, right? So my input, what are my input here? Input. Yeah.
Input is enter your first name.
Yes, my first name and last name. These are input, right? And what is my last output here?
Display your
Full name. Display is operation.
Okay.
Full name.
Full
My
name.
output, right? Expected result, right?
Yes.
And what are there's some operations over here? Concatenate. Concatenation is the operation, right?
Yes.
Okay.
Mahadir.
I got to read.
10 more minutes. Almost. So now Munim, understand? Are you getting interest?
Kind of.
Okay, that's good. So are you getting interest how to, so now you understand what is an algorithm. Algorithm is a step-by-step process to solve a problem, right? So what is our problem here, Mahdi? What is your problem here?
Name.
No.
Writing it first and last name.
No.
Find
So
your full name.
I have to. My problem is that I have to enter my first name and last name, and I have to display my full name. Right? This is my problem, and this is the way to solve this problem. I can write. I can depict my solution by drawing a picture or a flowchart, or by writing some pseudocode, or definitely by writing a program code. But we will start from writing a flowchart, because flowchart is easy to write and understand, right? Okay, and so then so flowchart, it has some specific blocks diagram, right? Specific shapes. We have to use for input. We have to use parallelogram. For output, we have to use parallelogram, right? For concrete operation, we have to use rectangle. So this sometimes is called hazardous, or is difficult. People do mistake. Yeah. So this is instead of drawing a flowchart, writing an pseudocode is better and easier, right?
And where is pseudocode here?
Yeah, this is the pseudocode. Whole thing is pseudocode.
Ah.
The P
This is
is
suitable.
silent.
And it is a naive pseudocode. Naive is very simple pseudocode. Naive means it may not be perfect. This pseudocode may not be perfect, but it seems perfect, right? But we knew that there are some elements of an algorithm, right? It should be precise, it should be complete, it should be unambiguous, right? Huh? And it should have some level of abstraction, right? So what are the level of abstractions here? What are the abstractions here?
Like it gives to me information.
It says enter. We don't know how to enter. We don't need to tell how to enter. We don't just we are typing enter your first name and last name, right? We are not giving in detail how to enter my first name and how to enter my last name.
Okay, so enter is the abstract here.
Yes. Just we are giving a shortcut, right?
The main.
Yeah. Yes. And then we are saying then concatenate, right? We are saying as just add group these two words, right? We are not telling in details how to concatenate.
Yeah.
Right? For instance, display, the word display over here. We are not telling how to display, where to display. Okay, do I need to display on computer monitor, or do I need to display on board,
Any.
or do I need to display in a piece of paper or print on a piece of paper? Anything. Okay, so any is just a give an abstract idea, you can do the easiest thing. Display means display. Computer monitor, that will not cost you or take time for it, okay? And it has a beginning point and an ending point, right? So that is it. This is a complete, right? And there is no ambiguous in it. Okay, so why do we say this is a naive algorithm? Naive pseudocode, naive algorithm. That means it has some problem. Naive means very basic. This is not perfect.
It's basic because it's just saying it doesn't give details of the full thing.
Yes, for instance, if you enter your first name and if you enter your first name is Mohaimin and last name is Munim, and if you form your full name as Mohaimin Munim without giving any space between Mohaimin and Munim, between your first name and last name, right? It would not look good, right? So this algorithm, it does not say give a space between first name and last name. In general, we use a space between first name and last name when you display one name, right? But this algorithm, it does not say that. Right? So still we have scope to improve it.
But that's just like, we know that we should process.
Yeah, we know that, but when we know that, but usually in computer, when you write a computer, you have to give that instruction. Otherwise, your program will not know.
No, otherwise a person would not.
Yes. Okay, so that means still in this is I'm calling this as a naive algorithm pseudocode. Okay, still we have scope to improve it, right? But it's a good start point. Good start. Okay, in order to start writing, okay, algorithm, you don't need to be perfect at the beginning, very beginning. Okay, so in order to be successful in this course, you don't need to be perfect at the beginning. But what you need to start from something, from a scratch. And when you write an algorithm or you get an algorithm, when you revisit it, review it, you may find some better way to make it improved. This is our goal, okay, in this course, that you will learn something when you see you get an algorithm, okay, and then you see that if you review it, you may find a better way to make it better. You may find an alternative algorithm. So this is why an algorithm is always may have some alternative ways to him to get a better way. Some algorithms are better, some algorithms are good, and there will be a perfect or best one. But definitely you don't need to think that, oh, don't worry that your algorithm is not a perfect, the best one. Okay. Okay. For instance, okay, we are almost end. Okay, this is my last one. Okay, so okay, let us start with another problem. For instance, if you are asked to find, look at this algorithm. Okay, what is that? Write an algorithm to enter an integer number and tell whether it is an even or an odd number. Okay, so how do we do that in general? In general, right? Okay, so let us do a quick activity. Okay, so this side, right side, Mahdi, and left side, Munim. Mahdi will tell a number, and Munim will tell whether this number is an even number or an odd number. Okay, tell a small number, not very big number. Okay, an integer number, full number, and again Munim will tell a number, and Mahdi has to tell whether it is an even or an odd number. Okay, you don't need to think. Okay, nobody look at the algorithm. Think about that. Okay, let us do this activity first. Okay, start, Mahdi.
2, 2,
2 even. Okay, another one more.
4,
4. Okay,
3,
3. One more.
7,
7. Odd. One more.
9,
9. Odd. Okay.
8,
8. Okay. Now Muni will tell some numbers, and you will tell whether this number is an even or an odd number. Okay. Tell a number.
72.4.
No, we have to tell a full number, an integer number, full number, not 0.4.
19.
19.
Odd.
202.
Even.
9,486.
Even. Even.
419.
Odd.
1,879.
Odd.
124.
Even.
No 0.4. You can rest the point.
24.
24. Even. Okay.
8,472.
Even.
980,400. 980,417.
Odd.
Okay. So, is all of the results are correct? Or are this result correct? Or did she do any mistake?
No.
Okay, so then quick question, how she did not do any mistake? Because how it is possible for her to quickly tell you whether your number is an even number or an odd number.
Because her brain is functioning.
Okay, and her brain is calculating and executing an algorithm. What was that algorithm?
Even or odd.
Even or odd? How to find an even or odd? How did she calculate whether a number is an even or odd?
She looked at the last number.
Yes, she looked at the last number. Okay,
No
and
matter what, how big is it? Okay.
no matter whether how big or large that number, she looked at the last digit, right? And found what?
Found that it's even or odd.
Yes. How do you know the number is even?
If it has 2, 0, 2, 4, 6, 8, or 10.
Okay. And this is a naive. This is the naive algorithm. This is the naive algorithm. And another way, do you know how do we say that a number is an even number? Can you think about a better algorithm?
If you divide by 2, if it's divisible by 2,
That's
no
an even.
reminder, then this is even.
Okay. Okay. How do we know that a number is an odd number?
If it's 1, 3, 5, 7, or 9.
This is a naive algorithm. Okay. And the better algorithm is
If you divide by 2 and find some reminder, then
1.
this is
Remainder is
odd.
1, right?
Yeah.
If remainder is 1, then
Reminder could be anything.
no. If you
Only
divide
one.
by any number by 2, remainder either 0 or 1.
If it's remainder 0,
Yeah, if remainder is 0, then is
even.
remainder is 1.
Then odd.
Yes. So
Okay. 0 is even, 1 is odd. It ain't no.
but if you divide any number by 2, your remainder always less than 2.
Yes.
So your remainder, you cannot have remainder 3.
Yes.
Okay. Okay. So the algorithm is here. You will is the pseudocode. You will begin and you will enter a number. For instance, here is n my number. Okay. And you will see n is n divisible by 2. If you say yes, then you will print that n is an even number, right? And if is no, it's not divisible by 2, right? Okay, then you will tell us that your number is an odd number, right? So here are 2 ways, right? 2. So here you see diamond sign over here. Diamond. It is a decision maker symbol.
Oh.
For diamond, you will do a decision making. Okay. So here you are saying what is the diamond here? Diamond says
Is this a decision here? Is
Yeah.
n divisible by 2? This
Yeah.
is a question. It's not a
yes, decision making. You are making a decision. You are taking a decision
The
over
way
here.
of decision.
Yes, a way to display a question to display a decision. So you are taking your decision based on this result, right? The question over here, right?
Yeah.
If your question result is yes, then you are going to right branch. And if your result is no, then you are going to left side, right?
Okay.
Okay. So is this algorithm precise? Is it a good algorithm?
Precise. But what is the answer?
Yeah, is it either if it is answer is either this side or that side, the right side or left side.
It's not unambiguous.
It's not ambiguous.
It is ambiguous.
What is ambiguity here?
It's yes or no, it's not clear.
Yes means is the number divisible by 2? All integer numbers will be either divisible by 2 or not. 2 Either will be divisible by 2
Or what?
or will not be divisible by 2. An integer number. If you divide by 2, either you will get remainder 0 or get remainder 1. If its remainder is 0, then it is an even number.
Yes.
And if its remainder is 1, then it is an odd number.
Yes.
So you have both conditions over here. But still you have scope to improve it. For instance, while asking Munim to tell us an integer number, still he was doing some mistakes, right? He was giving some decimal number.
Yes.
Okay. So then we can keep another branch, we can keep another switch, another here. So if he enters a non-integer number, then enter again. You could tell him the again. Go ahead. Let's repeat, right?
So integer number is like ABC.
No. ABC are not numbers. ABC are alphabet.
So enter an integer number.
N. So whatever number we are putting, we say N is that integer number. N may be 1, could be 2, 1, 300 or 400 full integer number. Integer means full number. We are denoting that number by N over here. Symbol, getting symbol.
Symbol.
Yeah, because after later that, instead of telling an integer number, I am telling is N divisible to. That means is N is my integer number. So then we are printing N. That means printing the number. We are not. So this is the shortcut.
Okay.
Yeah.
Symbol.
Yes. So this is an algorithm. Okay. So how we depict this algorithm? Yeah, we have depicted it using a flowchart. Right? Flowchart. Okay. Flowchart is one kind of picture. Okay. Now, following this flowchart, we can write a pseudocode. Okay. So what is the pseudocode over here? So this is, so we say enter an integer number n. Then the step is if n is divisible by 2, then
It's even.
print you entered an even number, right? Else if n is not divisible by 2,
It
then
should be odd.
print you enter an odd number, right? Else it may happen, you may tell me a character a, then I will say, oh, you did not enter an integer number, right? Else block here is optional, right? So this is a kind of pseudocode. This is a one kind of pseudocode. This is a naive pseudocode. But let us see, is it a complete code? Yes. It is. It has begin and it has end, right?
Yes.
Okay. Is it ambiguous?
No.
No. It's pretty good. Okay. Is it precise?
Yes.
Yes. Okay.
This means short.
Short. Okay. What are other attributes, properties of a good algorithm?
Correct.
Is it correct?
Yes.
Yes. Okay.
Precise. Correct.
Correct.
Clean. Unambiguous.
Unambiguous. Does it have some abstract thing? Yes. What are those things?
Like, so you know, abstract means like to fit for sure. Like, and more, like, they didn't, for most of them, they didn't give like a lot of detail. So, like,
Yes. It said there is a lot of detail. We say just print.
Print divisible.
Yes. We did not say the how to where to print. How to print. Okay. The shortcut.
Or how to divide.
Yes. And how to divide? We did not say how to divide by 2, right? So now our next step will be when we write our actual program, then we have to think, okay, what is the division sign, right? What is the division sign? How to find a remainder, right? So those are the symbol we will learn in our next class, inshallah. Okay. So for now, what we have learned. Okay, so this is a startup algorithm. Okay, so for instance, now if you start from here, from instance later you will see the typical algorithm like this. Okay, so this is the better pseudocode here. Okay, so better pseudocode, this previous pseudocode, it says if n is divisible by 2, right? So it did not say how to divide. So then this algorithm, it says if n, look at here, if n percentage 2, this percentage sign is the remainder sign. Remainder sign. Okay, it gives you a remainder. Okay, equal to 0, then print, you enter an even number. Else if n is percentage 2, n percentage 2, this percent is modulo operator. It modulo operator finds the remainder. Okay, is 1, then it is an odd number. So this algorithm is better than this algorithm.
The other one is better.
Okay, so when you revisit your algorithm time by time, day by day, you will learn how to make your algorithm better, updated and better, right? Okay, so this is the way of learning programming. And then your next step will be, then you have to think, okay, now I have a good steps, right? You have to use any programming language or one programming language. You can use Java, or you can use C# or you can use Python to write your program. Then your first step is, this is the process to learn programming. But instead of writing algorithm, you should not start writing program first, because then you will not understand. Okay. So once you understand writing this algorithm, this type pseudocode, this type what is called flowchart, then you will be able to understand your pseudocode in initial beginning pseudocode. Then you will be able to start writing a better pseudocode. Then you can see like write a better algorithm. Is like a better algorithm, or in a complicated flowchart, or a complicated algorithm. You see, this algorithm is this flowchart is complicated, right? Okay, so at this moment you will not understand this, but don't worry about this. Later, after 3, 4, 5 classes, okay, you will understand how to write this kind of complicated algorithm. Okay, so then you will be able to understand to write a program like this. Okay, so then what we have learned from here, we are done. Okay, 2 more minutes. Okay, last 2 minutes, give attention. So what are the components? These are the most, what are the components of algorithm? Data. Components, that elements of an algorithm.
Data.
It should have some data. It should have, okay, that's instructions.
Conditional
Expression, either conditional or control structures or modules. Okay, you will learn this later classes. Okay, what is like, for instance, in this class we have idea about data structure, that whole data, and then we have about instruction, then add to first name and last name, and then later we got some idea about conditional expression from here, right? If, else, these are the conditional, okay, instructions. And then later we will know how to control instruction. Control means, if here, if you can enter an even number, your first block will be executed, and then else block will be skipped. Okay, so if we enter an integer number, even number, so then if your number is 4, right?
Yes.
Then you will execute your first block, if block.
Okay.
Then else block will not be executed.
Okay.
Right? And if your number is 5, odd number, then your if block will not be executed. Then this block, this print, when we see that if your number is 5, then first block will be false, right?
Yes.
That block will not be executed. Next middle block will be executed, right? If your number is odd, you will print odd, right? A number cannot be odd and even at a certain time, right? A number will be either or even or
No.
or. So either of your block will be executed, not all of these 3 blocks, right?
Yeah.
One of these block will be executed. So this is the actually this is the control structure. We will know that later. Okay, and the module, that function, for instance, where we are saying that here print. Okay, we are saying print, or sometimes we will say add. So we will know how to print and how to do add operations. That are called modules. Okay.
Looking related components.
Abstract components. So let's say we are just saying print over here. So we don't know how the print method works over here, print operation works here. Later you will understand. Okay. So then, okay, we are on the last slide, conclusion. So what did you think? What you have learned from this class? Okay, one of the things that we have got an idea that algorithmic thinking is the crucial for success in computing. In order to learn computer programming, you have to learn algorithm first.
Yes.
Okay, algorithmic thinking result in algorithm development. You have to, if you think algorithmically, then you will be able to develop an algorithm, right?
Yes.
Okay, then program development start with algorithm development. You should not start writing program first. You should start writing algorithm first. When you are able to write algorithm, then you will be able to write pseudocode. Then you will be able to write program code. Okay. Then what is an algorithm? A set of instructions to perform a specific
that are accurate to
task.
do
Okay. What is an algorithm? An algorithm is a set of instructions, okay, to perform a specific task. Okay. So then abstraction is a description of an idea at a high level with little details. Alright? Abstraction will not say detail. It will give an idea. Okay. So implementation on abstract idea is the algorithm. Implementation of an abstract idea, for instance, how to go to downtown. If you implement those processes, that is the algorithm.
Basically, implementation of an abstraction
Idea is the algorithm. Yeah, how you implement an abstract idea, so that is the implementation. That implementation process actually is the algorithm. Is your algorithm. So an abstract idea can be implemented in different algorithms. So for instance, if I ask you to bring a flower, you will bring either a rose or a chameli or other kinds of tulip. Okay, those are either chameli or rose. Those are concrete implementation of the term, abstract term flower. Flower is an abstract term over here, right? Okay. And if I ask you to bring a flower, so when you bring a flower, a rose is implementation that you are bringing. You are following my instruction, right? You are solving my problem. So that is algorithm. Okay. A good algorithm should be exhibit precise, clearly, and complete correctness and simplicity. Okay, so writing a raw page long is necessarily be a good algorithm, right? Your algorithm could be short. Okay, an algorithm can be described using a natural language or a picture that we call flowchart or pseudocode or a specific programming language. Okay, later we will see that how we can implement our algorithm using programming language in a program. There are 4 ways, there are multiple ways to describe an algorithm.
Okay.
So, in this class, we learned 3 ways, right? To write an algorithm using a picture and diagram, that is called, we call that flowchart.
Yes.
We learn writing pseudocode, and we already know in natural language description. And later we will learn
And
how to write a computer program.
This one.
Yes, but in order to start writing a program, we need 2 more classes. Okay, we need 2 other classes in order to learn the basic things, theories. Okay, after 2 more classes, you can start learning. You can start describing your algorithm with computer programming language. Okay, inshallah. Okay. So you learn something new, Madi. You learned something new today, and Munim? Did you learn something new? No? You learned something new?
Yes.
Is this interesting? Kind of.
Yes. Thank you so much.
Madi?
Yes.
Okay. Okay, so you can review this video again, and you can watch it, and then inshallah in our next class we will go to the other part. Okay, thank you so much.